I have a couple of questions. I don't know how many I'm allowed to ask. So my first question is, how can soft plastics be integrated into the construction industries for buildings? Because I think you mentioned something about that. So how is it possible to utilize them as building construction materials? And the second question is, how does carbon capture actually work? Like, do you bury the plastic bottles near trees and they absorb the carbon content of the bottles, or do you plant trees in industrial areas and then the trees absorb them and keep them? I'm so sorry. And how the carbon that is also captured, how do you extract it one, and then how do you change it into the currency that is carbon credits? Because, like, I don't know, it's just for the layman that I am in this situation. Thank you.
Right. So I'll start with the first question. How do you integrate soft plastics into construction chemicals? First of all, the question should you integrate plastics into a certain value chain? Because the fact that when you have a hammer, everything looks like a nail, right? And instead of, I see a prevalent solution, quote unquote, where people try and bring composite materials together that don't have any sustainable end of life options. Because think of it, is this going to become construction and demolition waste that will then just be discarded? So you typically want to stick with monomaterials, except you're starting from the chemical building blocks that you use to manufacture and add mixtures that go into construction chemicals. So you want to stay away from bringing composite materials together as much as possible, and instead look for other high throughput applications. Like, can we go back to the building blocks that we can use to make other specialty chemicals? Can we go to what's the holy grail of material flow, which is closed loop circulation? The material that used to make something can go back infinitely and be reinforced for that same purpose. So there's that. The fact that you have a hammer, just be careful so that everything doesn't look like a nail and you want to apply the same situation, same solution to every scenario. Now, on carbon capture utilization and storage, so I'll start with carbon credits. What usually happens is there's a flow of material, so there's a carbon footprint or a carbon emissions, and again, it's not just carbon, it's greenhouse gas emissions, right? So you say, where does it come from? Where's the input? Where's the output? So you do a balance of, there's this thing in chemical engineering called the material balance. It's basically an equation that shows you what is going in, what is coming out, garbage in, garbage out. So you do that carbon accounting, showing where carbon is going out, coming in for a particular activity, and then you assign a carbon footprint to it. Now, if you are acting as a carbon sink, it means you are using carbon, because sometimes in construction materials you need CO2 to be integrated into materials, right? For chemical processing. So if it's a carbon sink, that means you get a certain amount of value for the amount of carbon that you're taking in, right? And if it's a carbon source, you are, well, in some cases penalized, but you're disincentivized to do that if you're putting out carbon. So that's how the credit system works, right? So where are the carbon sources and sinks? Can we do a balance of greenhouse gases on your process? If it's taking in carbon or reducing emissions, then you're positive and you get a credit. Is that correct? Now, carbon capture, utilization, and storage. And you very quickly discover that in the same way that technology is specialized, each solution sort of has to delve deeper into it, and it's like a whole different field. So the way it works is that you convert, depending on the form in which you have the carbon, but typically this is CO2, atmospheric CO2. So that is captured, and it could be then densified into solid forms, and sometimes that's isolated. Some people are trying to pure from carbon, so it goes from gas. You're trying to trap it in solid form so that you can use it as a pure, or so that you can bury it somewhere. So you can capture carbon, you can use it, or you can store it and isolate it. So I like to make a joke that the destiny that was for radioactive elements and radiation, which is deep isolation, has not come to this happen yet. So I hope that answers your questions. Oh, okay, not exactly. Let's talk after so we don't out. Thank you.
Yes, let me just add to that in as simple as possible. I don't think that, so imagine you have the mangroves, yeah, and you have the industrial, like an industrial city. One is, and planes flying, one is emitting the bad gas, one is emitting the good gas, yeah. So it's not like you're going to, it's offsetting each other. So if you listen to, was it Hein? If you watched his presentation, they would accord a certain, so let's say 10 trees, or is equivalent to this amount of carbon credit. So it's as simple as that, okay, if you have 300,000 in this place, when you divide it by 10, 10, 10, then you have your equivalent of carbon credit. And then on the upside, the industrialization, the gas emitting, so that is why data and statistics, like they are saying, is very important. So simply put like that, it is not a case of, but do you understand it a bit better now? All right.
That was my layman explanation as well. I go to